On today's show, we're going to take this awesome tool and totally make it more awesomer by adding a helical head.
Hit it!
Although helical heads are really gaining in popularity these days, most jointers, I think, are still sold with straight knife cutter heads, and that's what I've got right here. Basically, it's got 3 blades. Those blades need to be sharpened periodically, so you'll have to remove them, put them back in, and then do the setup process again, which is actually quite a pain in the butt. And if you've ever seen our jointer setup and calibration video, you know exactly what I'm talking about. But don't let that scare you. Straight knives are great. We've been using them for a very, very long time, and they produce great results. This is the type of upgrade that's a creature comfort upgrade. This is not a necessity upgrade, because there are some great advantages to a helical head, but they don't make or break the woodworking process by any means. For me, I felt it was time to upgrade. Truthfully, I think the planer is really the first place you should upgrade to a helical head if you're going to, and then the jointer, I think, is a secondary upgrade. But either way, that's what we're going to do today. So let me show you what the helical head looks like and give you an idea of what properties make it so awesome. As you can see, the helical head has its name because of the orientation of these little cutters. It's also known as a segmented cutter head, and you can see why you would call it that too. Right? Each one of these inserts has 4 sides. Each one of them is a cutting edge if you want it to be, so you can loosen it up, turn it 90 degrees, and get a fresh, sharp edge. So if you get a nick, unlike a straight knife cutter, where you'd have to shift the whole thing, all we have to do is take the one that has the nick, turn it 90 degrees, and we're back in business with no calibration needed. Now these cutter heads don't come cheap, so if you're thinking about upgrading, you really do need to weigh your options and decide if the benefits are truly worth it. So for me, there are 3 primary benefits. Number 1 is cut quality. It's glass smooth, straight grain wood, no problem, and even figured wood comes out great on a segmented cutter head, and I use a lot of that stuff. So for me, it's a lot of time savings, a lot of effort savings, and I don't have to chew up as much wood trying to get through that tear out that is inevitable from a straight knife cutter head. The second thing is convenience. I don't have to send knives out for sharpening, and when I do replace one of these little inserts, that doesn't require any sort of calibration. Everything is pre-indexed, so it's a huge time saver and cuts a whole chunk of the calibration process with my jointer. Just cuts it out, which is a great thing. The other thing is noise. Now, if you're concerned about how much noise your tools make, a significant reduction in noise could be a very welcome thing. Now for me, I always wear ear protection, so it kind of doesn't really matter, but maybe you have a basement workshop or your shop is attached to your home, noise always matters, right? So if you could cut down on the noise, that would be a great benefit too. All right, so let's start out by doing a little bit, speaking of noise, a little bit of a sound test, and then we'll get into the actual replacement. While doing a simple jointing operation, I'll test the sound level from about 3 feet behind the jointer using a little Radio Shack sound level meter. Looks like the measurement peaks out at about 114 decibels. That's pretty loud. Let's hope the new cutter head proves to be quieter. Speaking of which, let's install that sucker. Anytime you work on a tool, obviously, you should unplug it. Now we need to strip this thing down, starting with the blade guard. I've got a Powermatic jointer, so things might be a little bit different with other brands. Loosen the bolts that hold the fence assembly in place, and then lift the entire assembly off the jointer. Remove the belt guard, and then remove the motor compartment cover. You may as well do a little bit of cleanup while you're back there. Now remove the belt by tracking it off the pulley. If you're having trouble, consider loosening the motor to give you a little bit more slack. Loosen any set screws that are holding the pulley onto the shaft of the cutter head. Now using a gear puller, remove the pulley from the shaft. Now unfortunately, the puller I'm using is just a bit too small for the task and I got impatient, so I just used light taps with a wooden mallet to work the pulley off of the shaft. And be sure not to lose that little metal key, you need it. Now lower both the infeed and outfeed beds to their lowest points. You may need to remove a stop bolt or 2 to get them low enough. Now here's the trickiest part of the entire installation, loosening the bolts that hold the cutter head to the jointer body. The one in the back was pretty easy to reach. Once loosened, I was able to unscrew it by hand. The front bolt was a different story. I had to slide the wrench into the small slot between the jointer body and the stand. As the bolt moved downward, it eventually came into contact with the stand. I realized that the only way to get the bolt out any further was to actually lift up on the cutter head and provide clearance for the bolt head to turn. Once loosened, the front bolt is pretty much captured and stays right where it is. The head then slides out easily. Now we need to remove the bearing and the bearing housing from both ends of the cutter head. I found the dog hole in my workbench to be pretty handy for stabilizing this thing. Now that little gear puller that let me down before is letting me down once again. That's the last time I borrow a tool from a neighbor. Now this time, I'm not willing to risk breaking something or bending the shaft, so I head to the local auto parts store. Turns out you can rent a nice gear puller for a $30 deposit. Now this bad boy works as intended, pulling the bearing housing off with even and consistent pressure. Oddly enough, the bearing itself came off at the same time. The best thing about this gear puller is that it didn't cost me a dime. When I returned it, I got my full deposit back. Now on the other side, the bearing housing comes right off, but the bearing was still nice and snug. Another job for the gear puller. As you can see, the bearing comes off rather easily. Now it's a good idea to wipe down or vacuum the bearing and the housing to remove any dust or debris. The head comes packed in a dense cardboard box reinforced with 2x4 stock. Since it's free to spin, I use that to my advantage and roll some masking tape around the head to not only protect the cutters but my hands as well. Now to put the old bearings on the new cutter head, I'm using a deep well socket. The goal is to tap the bearing into place with even pressure, and the socket is sized so that it rests on the inner metal ring of the bearing. When the bearing stops moving, it's fully seated on the shaft. The bearing housing goes on next with just a few taps. Now repeat the process on the other side. Now we can slide the new cutter head back into position. If everything was installed correctly, the bolts should line up with the holes in the bearing housings. Tightening the bolts is almost as much fun as loosening them, but patience and diligence will pay off. Now the pulley goes on the same way it came off. Just be careful to line up the keyway and put the key in place. Replace the belt by tracking it onto the pulley, and once again watch your fingers. Drop the fence back into position and tighten it down. Now remove the masking tape to expose the beautiful helical head. Of course, the joiner beds now need to be set properly, which only takes a few minutes. Refer to episode 118 for more details on that process. Now let's make a few test cuts. I can already feel and hear a difference in the performance. Let's see what the sound meter says. So it looks like we have a peak at about 94 decibels. When compared to our results from the straight knife cutter head, we see a 20 decibel reduction. As you can see, that is a significant difference in the noise level. I actually didn't anticipate it being that dramatic, but according to that little sound meter, it's pretty significant. Okay, now that was a board of cherry. What I'm really curious to see is how well this thing does with something that's highly figured. Now check out this piece of quilted maple. This is one of my most prized boards, and that's why I keep it around. I'm afraid to use it, frankly. But I will give it a little pass and just see what kind of results we get off of this segmented cutter head. Now, I used a pencil here just so that I could see what was cut and what wasn't. The board does have a little bit of a bow to it, so at the trailing end here, you could still see some pencil, which means I'm not really making full contact here. But look at this. You see the divots taken out? This is from the old jointer, from the straight knife cutter head. So let's look at the area a little bit ahead of this where I know we made contact with the blades completely. It's nice and smooth, there's no tear out. And when you've got a wood that's as gorgeous as this is, you really want to save as much as possible. So taking as few passes as possible and getting the least amount of tear out as possible is critical for maintaining the thickness of the material. All right, so can't argue with results like that. Now, I just want to reiterate that this is not a mission-critical upgrade. It's a great upgrade, but it's not one that's going to make or break your woodworking. So if you're in the market and you like the benefits that we discussed and you work with a lot of figured wood and you don't want to go through all the extra work involved in changing knives and calibration, a segmented helical cutter head is probably something that should be on your list. All right, thanks for watching.